All right, 8th grade math. Today our learning goal for lesson 13 is to find ways to test congruence of interesting figures. Not just the vertices. Here we have trapezoids. In the figures below or on the screen, these trapezoids, A, B, C, D, and A prime, B prime, C prime, D prime are congruent. Your goal is to draw and label the points on A prime, B prime, C prime, and D prime that correspond to E and F. So if we're looking at E, we can see right here that from A to E is 1 unit, okay? So that means on our figure over here, our prime figure, our image, we also need to go from A 1 unit, which would then place our E prime. Okay, same thing with F. We can see that F is halfway between this coordinate and this coordinate, so we're going to do the same thing over here. The other object you could use is some tracing paper to get you there as well. In the next one it says draw and label the points on A, B, C, D that correspond to G prime and H. So, and I forgot to label this one our F prime here. Okay, and now we're looking at H prime. You can see that H prime is directly between A prime and B prime, which means where that line intersects, we're also going to draw an H over here. G prime is 2 units from D prime, so we're going to go ahead and find 2 units from D, and that would be our G. Notice that I labeled the objects in our pre-image with just their letters and the objects in the image with the prime value. Now you need to draw and label at least 3 more pairs of corresponding points in your workbooks. Please pause the video and come back in a few moments to check and see what it could look like. Here's another example of what your figures might look like with the pre-image coordinates and the image coordinates and their distances. We're trying to determine if any of these ovals are congruent to one another, and then we're going to explain our reasoning. We're going to try and do this without using any form of patty paper. So what we're going to look at is how much space they take up, because remember that if they take up the same space, then they're congruent objects. So this one has about 2 holes, and then it's got, that would be about 3 and maybe a quarter. So we can look over here. There's 2 holes here, and then they've got the same parts. So it appears to be that A and B are congruent ovals. And you can also see that here, this is 3 units by 2 units. Same thing goes for this oval. When we look at this one down here, this one appears to be 2.5 by 2 units. That one won't work for there. This one here is 2.5 and by 2. So therefore, are any of these congruent? Well, if their areas are displaying similarities, then I would consider that A and B are congruent, and C and D are congruent. Here are 2 congruent shapes with some corresponding points labeled. Our first step is to draw the points corresponding to B, D, and E and label them B prime, D prime, and E prime. Next, I'm going to measure the segments AD, A prime, D prime, BC, B prime, C prime, and AE, A prime, E prime. What I found was that AD and A prime, D prime are congruent, CB and C prime, B prime are congruent, and EA and E prime, A prime are congruent. In question number 3, it's asking you if you think there could be a pair of corresponding segments that would be different lengths. As we've studied over this unit, you can see that these are rigid transformations, which means that no, there would be no segments that were not congruent. This lesson concludes that rigid transformations do not change the distances between points. Therefore, these are all congruent segments in congruent figures. Okay, we're supposed to determine if these spaces are congruent and explain your reasoning. So I have traced on my patty paper right here this first object. I am going to translate it over and see if they line up. And it looks like, I'm going to use my pen. It looks like they line up. However, if I trace through here, you can see that my other object has its eyeballs moved a little bit more outward, and its mouth is down a few units and a little bit rotated. So that would be your explanation, just that it doesn't fit perfectly over top. So these faces are not congruent. So with this lesson coming to a conclusion, let's keep in mind that two figures are congruent when there is a sequence of translations, rotations, and reflections matching up one figure with the other. In order to show that two figures are not congruent, it is enough to find corresponding points on the figures which are not the same distance apart, or corresponding angles that have different measures. And this also includes that the distance between pairs of corresponding points in congruent figures is the same. Now, some figures, like the ones in front of you, are made up of several parts. They're each made up of 3 circles. These two designs include circles that are congruent, but in the left design, each circle touches both of the other 2. So you can see right there and right there, they touch both of the other 2. Whereas in this one, the center one is the only one touching the 2 outside circles. With the distance from here to here being this length, and the distance from here to here being that length, would clarify them the same. However, when we get to this one and this one, those are 2 different circles, which means here to here would have to be that same length as well. 8th graders, have you reached your learning targets? Can you use distances between points to decide if 2 figures are congruent or not? I hope that answer is yes. Now you can continue on to your Lesson 13 practice problems. Keep in mind they need to be posted on Canvas when they are completed, and ask any questions if you have them. I hope you have a great rest of the day.